Yes, good morning, my dear friends, and welcome to physics online classes. Here in the last class, we are discussing about the types of extrinsic semiconductor. We are discussing the types of extrinsic semiconductor. Maybe you have completed the N-type and P-type semiconductor. In extrinsic semiconductor, you have done the types, that is N-type and P-type semiconductor. As you know already, and extrinsic semiconductor, that is nothing but it is called impure semiconductor. It is also called as doped semiconductor. And doping nothing but by adding the impurities to increase the conductivity. That is nothing but doping. And what type of impurities we are adding? What type of impurities we are adding to a pure semiconductor? You have done the types of semiconductor. It may be the P-type semiconductor or it may be the N-type semiconductor. And maybe today we are going for the lecture number 6. We are going for the lecture number 6. And here, as I said in the last class, a pure semiconductor by adding the pentavalent impurities. A pure semiconductor by adding the pentavalent impurities, that becomes a N-type semiconductor. And as you know, the added impurity that acts as a positive ion. And also we know the N-type semiconductors also called as donors because they will donate one electron to the conduction band. And also we know in the N-type semiconductor, the majority carries the electrons and minority carries the holes. It means the electrons are more, holes are less. And also the N-type semiconductor is totally electrically neutral. And also we discussed in the last class about P-type semiconductor. The P-type semiconductor, nothing but a pure semiconductor by adding the traveling impurities. A pure semiconductor by adding the traveling impurities. It may be a boron or pure aluminum. And if we add the traveling impurities to a pure semiconductor, that becomes the P-type semiconductor. The important thing in the P-type semiconductor, it is also called as acceptors. The P-type semiconductor is also called as acceptors because, as we know already, our pure semiconductor having the 4 valence electrons. Our pure semiconductor name is silicon or germanium. They are having the 4 valence electrons. But as our boron or aluminum, they are called trivalent impurities. It means they are having the 3 valence electrons. They are having the trivalent impurities. It means our aluminum, boron, they are having the 3 valence electron. And whenever we are adding the boron or aluminum to a pure semiconductor, then what happens? As our boron or aluminum having 3 valence electron, they will make the covalent bond another 3 of our silicon or germanium. But we want 8, but we are having only 7. It means 1 covalent bond is incomplete. Because actually we want 8, but we are having 4 plus 3 or 7. But one we are having the 1 incomplete bond. That incomplete bond, that deficient 1 electron, nothing but holes. Deficient 1 electron or 1 incomplete bond is there. Because of 1 incomplete bond, because of 1 deficient electron, or having 1 vacant piece of electron, that vacant piece of electron or deficient electron, nothing but hole. It means, as I said already, the P-type semiconductor also called acceptors because to fulfill the covalent bond, the 4th covalent bond, they will take 1 electron from the neighboring and then they will fulfill that bond. Then only the bond completes. That's why they are called acceptors. To fulfill that covalent bond, they will take 1 electron from the neighboring. That is nothing but they are called acceptors. And also I said in P-type semiconductor, no doubt the holes are majority carriers and electrons minority carriers. And also in the P-type semiconductor, they are also called acceptors. And as I said already, whenever you are adding the traveling impurity, maybe boron or aluminum, that added impurity, that becomes the ion, that becomes the negative ion, that becomes an ion. It means we are adding boron or aluminum, that added atom, that becomes the negative ion. This is about you studied in last class. And also I said the most important thing about the difference about the p-type and n-type semiconductor. As we know, the first difference about n-type and p-type. First difference, the n-type nothing but a pure semiconductor by adding the pentavalent impurities. That is nothing but n-type semiconductor. A pure semiconductor by adding the pentavalent impurities. That becomes the n-type semiconductor. P-type nothing but a pure semiconductor by adding the trivalent impurities. That is nothing but p-type semiconductor. And second one, in n-type semiconductor, the majority carries electrons, but in p-type semiconductor, the majority carries holes. And about minority carriers, in your n-type semiconductor, minority carriers the holes, but in p-type semiconductor, minority carriers electrons. And next one, the Fermi level. The Fermi level in n-type semiconductor is very near to the conduction band, but in your p-type semiconductor, the Fermi level is near to the valence band, and also the density of electrons is more in the n-type semiconductor, and then density of hole will be more in the p-type semiconductor. And in n-type semiconductor, current is because of electrons. In p-type semiconductor, current is because of holes. And finally, we can say about n-type semiconductor, we are adding the phosphorus or arsenic. But in p-type semiconductor, we are adding the aluminum boron. This is about the important difference about n-type and p-type semiconductor. As I said in the last class, if we consider the single n-type semiconductor, if we consider single p-type semiconductor, we are having very less advantages. There are less applications. And because your n-type semiconductor or p-type semiconductor, they are electrical neutral. It means your p-type semiconductor or n-type semiconductor are electrical neutral. That's why if you use the single n-type semiconductor or p-type semiconductor, you are not doing more applications. And if you combine both, if you combine the p-type and semiconductor, we are having so many advantages. Actually, it is called p-n junction. The p-n junction is the heart of the semiconductor devices. In every semiconductor device, we are having one or two p-n junctions. The p-n junction is nothing but the combining the p-type semiconductor and n-type semiconductor. Today we go for that. We go for the p-n junction. We go for the p-n junction. We go for the p-n junction. Okay, it is so important device in electronics, or it is so important device in physics for semiconductors. Because as I said here, if we consider only the p-type semiconductor or we consider only the n-type semiconductor, we are having the very less advantages. We are having the very less applications. And if we combine a p-type semiconductor and n-type semiconductor, we are having so many advantages. As I said, it is the heart of the semiconductor electronics or semiconductor physics. And how to combine the p-type semiconductor and n-type semiconductor. It is not mechanical. We can take one piece of p-type, take one piece of n-type. We can't combine them mechanically. We are having some special techniques. We are having some special process. By some special techniques, we can combine. We can combine the n-type and p-type semiconductor. And now we'll go for how actually we can construct the p-n junction. The construction of p-n junction, or can say about the formation of p-n junction. The formation of p-n junction or the construction of p-n junction. We'll go for that. The formation of p-n junction. Look here, first what you have to do. First to take a small piece of semiconductor. It may be silicon or germanium. First what you have to do, take a small piece of semiconductor. It may be silicon or germanium. Next what you have to do, next by adding 1/2 portion of the trivalent impurities. And next by adding another half portion of the pentagonal impurities. Next, by adding another half portion of the pentagonal impurities. And the important thing, the separation between the p-type and n-type material, that is nothing but junction. The separation between the p-type and n-type material, that is nothing but your junction. It means what is called p-n junction, nothing but your semiconductor by adding one side of the traveling impurities, by adding another half portion of the pentagonal impurities, and separating these two materials, that is nothing but junction, that is nothing but your p-n. And another way, first to take your semiconductor by adding one side of the acceptors and by adding another side of the donors and separating these two materials, nothing but your p-n junction. By adding one side of traveling impurities and by adding another half portion of the pentagonal impurities and separating these two materials, nothing but junction, is one way. Another way, same in another way, by adding one side of the acceptors and by adding another side with the donors and separating these two materials, nothing but the p-n junction. Right? And actually, if you go for in detail, you are studying in higher level, actually another way of explanation, first you take a pure semiconductor with silicon and germanium. Next, what you do, by adding one half portion can diffuse the p-type semiconductor. Another, by the diffusion can add the pentagonal impurities. Diffusion, by the diffusion process can construct the p-n junction. It means one side diffuse the p-type semiconductor, another side diffuse the n-type semiconductor, and separating these two materials, nothing but the junction. By diffusing the one side with the p-type semiconductor, another side with the n-type semiconductor, separating these two, nothing but junction. This is about the formation or construction of your junction. And look here, the important thing, yesterday we discussed already, in your, what happens if you join the two p and n-type semiconductor? What is the effect? What is the important property? What is the main function of when joining the p and n-type semiconductor? What is the most important thing? What is the main function? And what is the main advantage if you join the p and n-type semiconductor? And for that, before that, you know about the p-type semiconductor. What is inside the p-type semiconductor? What is inside the p-type semiconductor? As we know, in the p-type semiconductor, having the holes, no doubt, the holes are more, and also we are having the electrons are there, and also as I said, we are having the, this is p-type, we are having the p-type, we are having the some negative ions. There are also some negative ions. It means it contains the negative ions. It contains the negative ions. No doubt. We are having the holes or majority carriers, and also electrons also there, and also we are having the negative immobile ions. As I said, the added impurity in p-type semiconductor, we are adding boron or aluminum. That added impurity that acts as a negative ion. It means inside the p-type semiconductor we are having the holes of majority carriers and electromagnetic carriers, and also we are having the negative ions. They are called immobile ions. And similarly, for your p-type semiconductor, what is there inside that? No doubt, you are having the electrons or the majority carriers. The electrons are the majority carriers. No doubt, the electrons are the majority carriers. And also we are having some holes. And also we are having the immobile positive ions. We are having the immobile positive ions, like that. Immobile positive ions. Why we are having immobile positive ions? That added impurity. It means arsenic or phosphorus. That acts as an immobile. It means whenever you are joining or combining a p-type and semiconductor, what happens? You see that. It's so important. The studying in detail about that. That is so important concept in your p-n junction. That is something but the formation of depression rate. The formation of, so important thing, the formation of depression rate. The formation of depression rate. So so important. Once you understand this, you understand very easily about your diodes, formation of depression loop. Look here. As I said here, you consider a series semiconductor, you draw very big diagram. Then you understand easily about how we can form the depression loop. Formation of depression loop. This is your P type. This is N type. Look here, as I said here, otherwise I can write afterwards. This is right here. Right here. This is nothing but you are having the holes or without carriers, and also you are having yes, you are having electrons also there. Electrons also there. They are called minority carriers. And also you are having negative ions. You are having some negative ions. The negative ions, because of your added impurity, you are having some negative ions. Similarly here you are having the more electrons, no doubt. Because of the entire semiconductor, you are having the more number of electrons. And important thing here, as I said already, here having the holes are also there. Here having the holes also there. But important thing, here having the negative ions. Having the negative ions. Sorry, whenever you have done the PN junction, it means you have connected, you have done the combination, you have joined the P-type and N-type semiconductor. Important thing, how to join that? Keep it in mind, without destroying the crystal structure. The crystal structure continuous. How we are adding, how you are combining, how you are joining P-type and N-type semiconductor. Keep it in mind, without destroying the crystal structure. The crystal structure will be continuous. The crystal structure will be continuous. Like that you can add or join the P-type and semiconductor. And whenever you are joining or adding the P-type and semiconductor, what happens? As you know here the holes are without carriers. Here the electrons without carriers. It means what? Here holes are more, here electrons are more. It means as here the holes are more, what they will do? They will diffuse from higher concentration to lower concentration. It means here the concentration of hole will be more. Here the concentration of holes will be less. But here the concentration of electrons will be more. But here the concentration of electrons will be less. Actually, as we know, always the charges are moved from higher potential to lower potential. It means to make it compensate. Here, no doubt, the holes are very more. It means the concentration of holes is very more here. Here, the concentration of electrons is very more. Then what happens? Whenever you combine the P-type and semiconductor, what happens? The holes will diffuse from P side to the N side. Whenever you combine and joining the P-type and semiconductor, what happens? The holes, because they are more in concentration, the P-type semiconductor, what they will do? They will move towards the N side. They will diffuse from the P to N side. The holes will diffusing from P to N side. At the same time, the electrons in the N side, they will diffuse towards the P side because of the concentration difference of the holes and electrons. It means, as I said, in P-type, holes are without carriers. N-type, electrons are without carriers. It means what happens? Because to make it compensate, what happens? The holes, they will diffuse from P to N side. The holes, they will diffuse, they will move from P to N side. At the same time, the electrons are majority carriers. The concentration of electrons more here. This electron, they will diffuse towards the P side. The holes, they will diffuse from P to N side. The electrons, they will diffuse from the N to P side. This is nothing but the diffusion current. It is so important. The diffusion current. The diffusion current. What is the diffusion current? No doubt, the current because of the moving of the holes and moving of the electrons, that is because of the concentration difference. You are not applying any electric field, you are not applying any external voltage, but the electrons and holes, they are moving in a particular direction. Because why they are moving? Because of the concentration difference, because of the concentration gradient, because of the concentration gradient or because of the concentration difference, they are moving from, they are diffusing from P to N side and to P side. That diffusion of electrons and diffusion holes, that is nothing but diffusion current. It means the current because of the moving of the holes and electrons, because of the concentration difference, because of the concentration gradient, that current nothing but the diffusion current. That current nothing but the diffusion current. That current nothing but the diffusion current. It means the current because of the moving of the holes from P to N side, when electrons from the N to P side, or you can say in standard word, the holes are diffusing from P side to N side, and electrons are diffusing from N side to P side. This diffusion electrons and holes that combine each other diffusion current. The diffusion current nothing but the diffusion of electron and holes from N to P side, P to N side. That current, that moving of holes, electrons, nothing but current. As you know, current nothing but moving of charges. And here, as you know, in semiconductor, there are two types of current, two types of charge carrying between holes and electrons. It means the moving of holes and moving of electrons, that becomes the current. It means what is diffusion current? The current because of the concentration difference. Because the holes are moving, we are having the less concentration of holes. Electrons moving, we are having the less concentration of electrons. It means the diffusion of electron holes, that is nothing but diffusion current. It means the holes and electrons are moving because of concentration. That current nothing but the diffusion current. That current nothing but the diffusion current. And actually another current also it is there, that is called drift current. That is called drift current. Actually, the drift current, no doubt, here also electrons are holes moving here because of the electric field. Here the electrons or holes are moving because of the electric field. Here you are not having an electric field. Here the current is because of the concentration difference. Here the current is because of the electric field. This is nothing but drift current. This is nothing but the diffusion current. And now we will go for another important thing. What is called the depression layer? What is called the depression? It's very important. The depression layer, so important. What is called the depression layer? Look here, as I said here. Look here, as the holes, they will diffuse from P to N side. Electrons, they will diffuse from N to P side. Then what happens? The sum of the holes, they will recombine with the electrons in the N side. And also, the electrons, some of the electrons, they will recombine holes in the P side. It means, as we know, whenever the electron hole recombine, what happens? They will be neutralized, they will disappear. Whenever the electron hole recombine, they will disappear and neutralize. And they will create some layer. They will create some layer like that. This layer. Actually, in this layer, you are not having anything. This layer, you are not having anything. They will create some layer. In this layer, what happens? We are not having any. What happens? As I said here, whenever the holes, they will move towards the N side, or they will diffuse from the holes, they will diffuse towards the N side, and electrons, they will diffuse towards the P side. What happens? Some of the electrons, they will recombine in the holes, and also some of the holes, they will recombine with the electrons. And whenever, as you know, whenever electron will recombine, they will disappear, they will neutralize, they will create this layer. In this layer, no electrons holes are not there because they will be neutralized. And actually, in this layer is nothing but your depression layer. This layer nothing but the depression layer. Actually, in this layer, what happens? As we know here, electrons are moving, holes are moving. But what about this negative immovable ions? What about this positive immovable ions? They will create a layer. That layer nothing but the depression layer. Here we will create a negative layer. Here they will create a positive layer. It means, as I said here, what I said here, no doubt the electrons are moving here and holes are moving here. What about this negative and positive ions? They are not moving. They are not moving because they are immovable. They will create some layer. This layer nothing but the depression layer. But important thing, why it is called depression layer? Here you are not having any electrons, you are not having any holes. This layer only having the immovable ions. It may be a negative ions or it may be positive ions. This layer is depleted of charge carriers. This layer is depleted of charge carrier. It means what? In this layer you are not having any electrons, you are not having any holes. How we can form this layer? Because as I said, electrons are moving, no doubt. The holes are moving, no doubt. But what about this positive and negative ions? They are not moving. They will be uncompensated. They are uncompensated. Because of this positive ion, negative ion, they will create some layer. This layer is called the depression layer. Important thing, in this layer, we are not having any mobile charge carriers. They are called immobile ions. The depression layer consists of immobile ions. Immobile ions. The depression layer is not having any charge carriers. It is not having any electrons. It is not having any holes. And this is one way to explain about depression layer. Maybe you follow. Once again, repeat. Very simple. As I said here, the holes they will diffuse towards the N side. Electrons they will diffuse towards the P side. What happens? Some of the electrons, some of the holes, they will recombine. They will disappear. They will neutralize. And what about this negative and positive ions? They are not moving. They will create some layer. This layer nothing but the depression layer. The layer consists of immovable ions. It may be negative ion and positive ions. That is nothing but the depression layer. The depression layer nothing but in this area you are not having any mobile charge carriers. This area you are not having any electrons, you are not having any holes because they will come up. They will be disappear. They will be neutralized. And only this layer consists of negative ions and positive ions. The negative ions are nothing but acceptor ions. Positive ions are nothing but donor ions. The donor ions from N side and acceptor ions from P side. They will create some layer. This layer nothing but the depression layer. This is one way. Another way also. As we know, here the electron they move towards here. What happens? Here if the electron they move towards here, what happens? This is nothing but deficient electron. The deficient electron nothing but you can say about they will create a positive charge. Near here they will create a positive charge. And in the same way, here having this electron here, what happens? Here more electrons. The more electrons they are having the negative charge. In the near to P side they are having the negative charge. Why we are having negative charge? Because this electron on this side. It is here you are having the more number of electrons. And if you are having more number of electrons, nothing but as you know electrons in negative charge. That's why near to P you are having the negative charge carriers. And near to N you are having the positive carriers. Because here is electron on this side. It means here you are having the deficient electrons. And deficient electron nothing but positive charge. Excess of electron nothing but negative charge. It means another way of the formation depression layer. It means this electron on this side, this will create a positive charge. And this here, this electron on this side, here I have more number of electrons. If you have more number of electrons, that is nothing but negative charge. This is another way of the formation of depression layer. But it is very simple, don't to confuse. As I said here holes are magnetic carriers and here electrons are magnetic carriers. What happens? The holes they will diffuse from P side to N side. Electrons they will diffuse N side to P side. And what happens? Some of the electrons will recombine and they will neutralize, they will disappear, they will create a layer. No doubt in this layer you are not having any holes, you are not having any electrons. But what is there in this layer? No doubt here you are having the negative ions from the p side and positive ions from the positive ions from the n side. They will create a layer. That layer nothing but the depression layer. The layer having the negative and positive ions, that is nothing but depression layer. And what is the importance of depression layer? What is the importance of depression layer? Look here, if the depression layer not formed, what happens? You are having this electron hole, they will be moving one side on the side, they will be neutralized, they will disappear. But you are not having holes, you are not having the electrons. To avoid, to oppose, to stop the further diffusion of electron holes, to avoid, to stop the further diffusion of electron holes, we are having the depression layer. Actually, the important property of depression layer opposes the further moving of the holes and electrons or further diffusion of electron holes, because as we know, these holes they will be repelled by the positive of the ion. These electrons, they want to come here, they will be repelled by these negative ions. It means they are not moving from n side to p side. And holes also they are not moving from p side to n side, because these holes have the positive charge, they will be repelled from this positive ion. This electron having negative charge, that electron will be repelled by this negative ion. It means we can avoid I can stop further diffusion of electron holes. This is the important property of the depression layer. The depression layer, once the depression forms, what happens? The further diffusion of electron holes will be stopped. The further diffusion of electron holes will stop, because as I said, electrons will be repelled by the negative ions and holes will be repelled by positive ions. It means further moving of electron holes will be repelled. This is the most important property of depression layer. The depression layer is a layer. In this layer, you are having only the immovable charge carriers. You are not having any electrons, you are not having any holes. And because of this layer, it is called immovable ions, because this layer is not having electron, not having any holes. And once the depression forms, what happens? It will be opposes, it will be stop the further diffusion of electron holes. And another important thing, another important property, the barrier potential. Barrier potential. This is also important. Look here, as we know already, this negative ion, this positive ion, they will create some electric field. They will create some potential difference. This potential difference nothing but it is called Vp. That is nothing but barrier potential. It means these negative ions and positive ions, they will create some electric field. They will create some potential. This potential nothing but the barrier potential. This negative ions and positive ions, they will create some electric field. They will create some potential. This potential nothing but the barrier potential. What is barrier potential? The potential created by the negative and positive ions. That difference, the potential difference created by the negative and positive ions, that potential nothing but the barrier potential. Or you can say the electric field created by the negative and positive ions. This electric field or this potential nothing but the barrier potential. What is barrier potential? The potential created by the negative and positive ions, or the electric field created by the negative and positive ions. That electric field nothing but the barrier potential. These two are important. What is depression layer? What is barrier potential? No doubt, the depression layer is a layer. It contains only the immovable charge carriers. It is having negative and positive ions. And in this layer, you are not having any electrons or holes. And how you can form the depression layer? That is nothing but electrons and holes are diffusion. No doubt, they will recombine. But this negative and positive ions, they will create a layer. That layer nothing but the acceptor ions, donor ions. They will create a layer. That layer nothing but the depression layer. And as I said, the important thing about depression layer is about it opposes the further moving of the electron holes. The depression layer will be opposes, stop the further moving of the electron holes, or they will stop the further diffusion of electron and holes. And what is called this barrier potential. The barrier potential nothing but the negative and positive ions, they will create some electric field, or negative and positive they will create some potential. That potential nothing but barrier potential. And as we know that barrier potential for silicon, that is 0.7 volts, and that is for germanium, that is nothing but 0.3 volts. The barrier potential for the silicon, that is 0.7 volts, and for germanium 0.3 volts. It means because we consider only silicon and germanium, in general consider only silicon and germanium. It means what is called barrier potential nothing but the negative ions and positive ions, they will create some electric field, they will create some potential. That potential difference or that electric field, nothing but the barrier potential. This is the important thing in the p-n junction. Whenever you are joining the p-type and whenever you are joining the p-type and semiconductor, what happens? You are having the formation depression layer. And once the depression forms, then what happens? The further diffusion of electron holes will be stopped. And also the depression layer, they will create some electric field, they will create some potential. That potential is called barrier potential. It is so important about the barrier potential. And last in the CT, what is the width of the depression layer? It is also called as barrier width. It is also called as barrier width. Barrier width. It is nothing but the distance between the negative and positive ions. It is nothing but the distance between the negative and positive ions. That is nothing but barrier width. That is actually in general having the 1 micrometer. We are having the 10⁻⁻⁶. That is the width of the barrier is about 1 micrometer. It means I am saying the distance between the negative and positive ions, or the area between the negative and positive ions. This area is nothing but the width of the barrier, that is about nearly 1 micrometer. This is about the importance about your p-n junction. We go forward. The important thing, as I said already, the p-n junction nothing but you have not take a piece of semiconductor, take a piece of p-type semiconductor and take a n-type piece of semiconductor. You cannot combine them mechanically. Take a small piece of semiconductor, n-type and p-type, it is not possible to combine mechanically. There are some special techniques, some special process. It may be the diffusion process, or it may be the as I said about simple way of take a small semiconductor by adding traveling impedance, by adding cut off impedance, or by adding acceptor one side, by adding on one side, or another way I said about diffuse one side with the p side, p-type semiconductor, diffuse another side with the n-type semiconductor, and separating these two nothing but your p-n junction. And as I said, the p-n junction is the heart of the semiconductor devices. The p-n junction is the heart of the semiconductor devices. And maybe still you are not applied any external voltage. Still you are not applying the external voltage. It means if you apply the external voltage, then what happens? If you apply the external voltage, then what happens? What is the effect of the external voltage? If you apply the battery, if you apply the external voltage to the p-n junction, then what is the effect? We go for that. And actually that is called biasing. It is called biasing. That is called biasing. Here what is called biasing? The biasing nothing but by applying the external voltage. You apply some external voltage here. By applying the external voltage to the diode, that is nothing but biasing. By applying this battery connection, by applying the external voltage to the diode, nothing but biasing. By applying the external voltage or by connecting the battery to the semiconductor diode or to the p-n junction, nothing but biasing. And actually you are studying in the tomorrow class, there are two types of biasing. One is called forward bias, one is called reverse bias. Forward and reverse bias. What is forward bias and what is reverse bias? Look here, if you connect the, as we know, the holes and the positive charge carriers, electrons are the negative charge carriers. It means if you connect the positive of the p-type to the positive of the battery, and negative of the battery to the N-type semiconductor. Connect the P-type semiconductor to the positive of the battery and connect the N-type material to the negative terminal. That is nothing but forward bias. Or you can say, actually it is also called as diode. It is also called as diode. PN junction diode. It is also called as, you can say about PN junction diode. So called as PN junction diode. It is called PN junction diode. You can see the symbol of PN junction diode. And here important thing, it is your P diode. Actually, what is diode? It is a two-terminal semiconductor device. What is diode? It is a two-terminal semiconductor device. Diode is a two-terminal semiconductor device. Actually, di nothing but two. OD nothing but electrodes. It is having two electrodes. What is called diode nothing but? It is having di nothing but two. OD nothing but electrodes. It is having two electrodes. And what is diode? It is a two-terminal semiconductor device. Diode is a two-terminal semiconductor device. It is so important about diode. And as I said here, what is forward bias? Nothing but the positive of the battery given to the positive of diode, and negative of battery given to the negative of diode. That is nothing but forward bias. Forward bias is nothing but the positive of the diode, positive of battery, negative of diode, negative battery. That is nothing but forward bias. Or the P-type semiconductor is connected to the positive of the battery. N-type semiconductor is connected to the negative of battery. That is nothing but forward bias. What about reverse bias? It means I am saying the same polarity, positive, positive, negative, negative. That is forward bias. What about reverse bias? This is reverse bias. Reverse bias will change the polarity. Or you can change the diode also. This is nothing but reverse bias. The reverse bias what happens? The positive diode, negative battery, and negative diode, positive battery. Reverse, nothing but opposite polarity. Positive diode, negative battery, and negative diode, positive battery. That is nothing but reverse bias. Or the P-type is connected to the negative of the battery, and the N-type semiconductor connected to the positive battery. That is nothing but reverse bias. It means it is called opposite polarity. It is called opposite polarity. And also you can mention by using the symbol of diodes. This is nothing but the diode symbol, and here you can connect a battery, and this is nothing but your P side, N side, and this is positive. This is nothing but forward bias. And same you can consider the reverse bias. This is nothing but the reverse bias. Here positive, negative. This is nothing but the reverse bias. It means I am saying the symbol. This is the block. This is the today's class. And in this class, you go for what is the effect of if you apply the forward bias, or if you apply the battery to the diode. If you apply the battery to the diode, what is the effect? Actually, I said another important thing: the direct current. What is direct current? Look here, this negative one, the positive of your VB barrier potential. Because of this electric field, no doubt, here what are they here? The holes are magnetic. That holes they move towards the N side, and this here electrons magnetic. That electrons they move towards the N side. That is nothing but direct current. The direct current is because of this electric field VB. The direct current is because of this VB. It means here the holes are magnetic. This holes they move towards the P side. Here electron magnetic. This holes here electron magnetic. This electron they move towards the N side. It means always the direct current and diffusion current they are opposite to each other. The direct current and diffusion current they are opposite to each other. The direct current nothing but because of the electric field, because of the barrier potential, and the diffusion current is because of the concentration difference. The diffusion current because of the concentration gradient or concentration difference. It means the direct current nothing but no doubt electrons holes are moving because of this electric field, because of the barrier potential. That is about the direct current. And as I said, in the tomorrow class you go for the what is the effect of applying the battery to the diode. If you apply the forward bias, what is the effect? If you apply the reverse, what is the effect? To go further to 1 plus. Thank you.